Okay, well, here we are. This is 48 hours later. Incubator's still on, which is great news. Let's go and check and see how these little guys fared. Okay. First of all, here is plus mask. Let's see here. Don't see anything. It's always good to look at things under a stereoscope to make sure. And here is minus mask. And there's somebody right there. Little guy. Now, what I didn't do was do the experiment with the mask where it's above, everything shoots out of the top of the mask, which doesn't stop anything, including the dreaded COVID. So that's something to remember. But hey, maybe the mask did a little something. So here is Staph aureus. You can see kind of what it looks like. That's better, I think. So that's Staph aureus. Notice there's only one colony type on there. In other words, I don't see a mixed type of colony. Each one of these little dots, these big blobs, is a colony. And notice this one is isolated. This one's isolated. This one's isolated. There's multiple in here that are isolated, but then there's a lot that are squished together. That group are smushed together, and then this is the initial inoculum up here. So you can see what you're going for. You're going for this. You're going for this colony. You're going for this colony, because those represent, a colony represents, even though it's not probably technically true, it represents it represents growth from a supposed single cell. So this would be, one clone. This would be another. So if you were taking and you're trying to isolate a plasmid from one of these, or you're trying to isolate a particular protein, you don't want to take your loop and grab over here. You want to take your loop and grab that colony right there. What you would probably do is take a Sharpie, and you would go, oh, this colony is super cool. I'm going to circle it, and I'm going to label it A. And then I'm going to do all my genetic work on colony A, for example. Okay? So, important, pure, and isolated. So Staph aureus worked. This one is Pseudomonas aeruginosa. Notice it looks different. Also notice I've only got 1, 2 isolated colonies, maybe 3, but because of the way this guy grows, even an expert like me can have difficulty in getting a pure isolated colony, because Pseudomonas, for instance, is very sticky, and so it's hard to get an isolated colony. And all of this work out here, I got nothing. All this is all mashed together. Only in those couple of places, in that last set of quadrants, did I get anything at all. But notice the difference in sort of what the colonies look like. The Staph aureus, which is this guy, they're very the edges of the colonies are very smooth, and there's not a lot of haze around them, and they're a different color. They're this kind of whitish beige. The Pseudomonas has almost a fried egg appearance. There's a little bit of edging that's different. They grow different. The color's different. So once you work on these for a while, you'd be surprised what you can figure out. These, by the way, Pseudomonas, are interesting because later on they'll make pigmentation. So this plate will turn like a forest green after a while. I'll let it go and show it to you later. But anyway, so there's Pseudomonas. Here's Proteus mirabilis. Oh boy. Now, look at that. Would you look at that? Do you see any isolated colonies on there? Notice that there's this goopy haze over the whole plate. Let me show you. Proteus is an interesting little dude. I'll cool my blue. I hope you can see this. Let's see. See? I clear the plate. Look at that. Oops. That's you. Okay. So that organism, Proteus, lives in your gut. You probably all got Proteus. It's a little gram-negative rod. It grows, it moves on a surface. It has a bunch of flagella. It's what's called paratrichously flagellated. And it just kind of swims along the surface of the auger, and it will spread out, okay? There's no way on God's green earth that you're going to get isolated colonies of Proteus because of the way it spreads, okay? Different type of organism already that we're looking at. That's kind of cool. So Proteus is really a cool thing to play with, but you're never going to get isolated colonies on it. Here's E. coli, our favorite. Okay? Everyone loves E. coli. Okay? Now, anybody notice anything about this one? Do you see isolated colonies on that plate? That would be a 0 in my grade book. I see no isolated colonies, maybe a couple if I look with a stereoscope, but basically that's a lousy plate, streak plate. Notice that's the tornado method. Okay, some people are really lucky with it. Not I. I have much better luck with my quadrant method. You do whatever works for you. But in this case, E. coli has a particular nice smell. Smell it? You know it's E. coli once you open the plate. Anyway, that's kind of distressing, but you know, hey, that's the way it goes. Here's Bacillus cereus. This guy's cool, and he's completely different than the other two. Completely different organism. Notice I got no isolated colonies on him, even though I use my vaunted quadrant method. And that's because, again, of how thick the stuff is and how sticky it is. This thing is an endospore former. This stuff, you can boil water with the endospores in it, and it will not kill the endospores. This is a very hardy little critter, lives in the soil. Really cool organism. But notice, isolated colony, much harder to get. Much harder. You have to probably, remember when I was doing the tango, and I was pulling and lifting and pulling and lifting? To get this isolated, you probably have to pull, flame, come back, drag, flame, come back, drag, flame. I mean, that's something you could try if you were stuck trying to isolate this stuff. Anyway, that's Bacillus. It's cool. And here's our pal, Micrococcus luteus. Remember I said he was yellow? Sure enough, he is. He's yellow. Now, this plate would be a 0 in the grade book. I got beautiful isolated colonies, multiple beautiful isolated colonies. Look at that. They're great. However, I don't know if you can see this too well, but I've got a colony up there that's different. I got those colonies are different. They're not yellow. They're white. That's a beige looking different shade than this yellow. These are Micrococcus. This isn't. I also have, lo and behold, look at all around the edge there. All that organism that's there, all that kind of cloudy stuff. You can see it right there on the edge here. See? This stuff? That is a contaminant. And how the heck did I put a contaminant in there? Because I'm such a genius and I've been doing this for 30 years. How on earth could that happen? Well, remember we had our problem with all the water? Here's the inside of the lid. Oops. Here's the inside of the lid. Do you see that little blob of yellow beige stuff in the corner there? And you can see where the water has run. That is because these plates are goopy. And that has run in. Even though I had it turned upside down, it was able to get it on the plate. So, this is very instructive. I hate it when I mess up. But this is very instructive of the kinds of stuff you have to do and how streaking a plate in pure isolated colonies is easy, but it's also deceptively easy. You can have problems. This is why when you turn in a plate of these for a grade, you might have to do it a couple of times. It might not work every moment. What we'll do this quarter is have you say streak 1, and then you'll incubate it, and we'll have Julie or me or somebody take it out of the incubator a day later or something, refrigerate it, and then you can come back the next time and we'll look at it and we'll see what it is. And if you need to, you can try to restreak it again for your pure isolated plate. But anyway, this is a really good example of what happens.